My name is Marcella Jurotich and I am representing the state of Nebraska. My previous study used graph theory to visualize the relationship between taxonomic diversity and functional group diversity at three discrete stream sites: a high-quality site, a medium-quality site, and a low-quality site. From this study, I questioned whether I could quantify the relationship between taxonomic diversity and functional group diversity and create a visual model. My current study is titled, Graph Theoretical Analysis is Effective in Modeling Interfunctional Relationships in Freshwater Ecosystems. Two hypotheses were tested. First, the taxa function complexity could be quantified along a continuum of 32 stream sites. And second, that compression or loss of edges leading from taxa vertices to functional group vertices would affect functional relationships. If successful, this study can be used to help indicate ecosystem health and function. Data were obtained with permission from a study done by Donley in 1999, which examined 32 stream sites along 16 streams. I then assigned functional groups to macroinvertebrate taxa, resulting in 79 taxa across 32 sites. In graph theory, the number of taxa fulfilling a functional group is referred to as the degree, and the relative degree is the proportion of degrees a functional group has in relation to other functional groups at a site. To convert the linkages between taxonomic diversity and functional group diversity to continuous data, the degree and the relative degree for each functional group were calculated, thus quantifying the relationship between taxonomic diversity and functional group diversity. A multiple regression was performed to see if the relative degree of the predator function responded to changes in habitat. A linear regression was also performed between the predator function and three other functional groups: scrapers, collector-gatherers, and collector-filters, revealing a relationship. Using data from minimally disturbed stream sites, an idealized model of interfunctional interactions were created, showing the relative abundances of the predator function and four other functional groups. Vertices from the signal flow graph visual model were then modified to represent the four functional groups from the 32 stream sites based off of the slope values from the linear regression. Both hypotheses were supported. The quantification of the relationship between taxonomic diversity and functional group diversity was successful. Furthermore, the novel method of the signal flow graph model was effective in better informing us about interfunctional interactions in food webs and freshwater ecosystem responses to habitat degradation and loss of taxa. This method of determining functional interactions can be used to mathematically examine ecosystem health and function in freshwater streams and other ecosystems.